and two sides in those triangles. So the following theorem and its converse involve the relationship between the sides of two triangles and an angle in each triangle. Okay, the first one, or the theorem we're going over today, is called the hinge theorem. It has to do with side angle side inequalities. So it states if two sides of a triangle are congruent to two sides of another triangle, and the included angle, it's because I leaned over the top.
Can I turn off the lights? I don't know, it's just not working. It's not like the front set.
I think that's the middle light switch. What's the end one? I don't remember. That one? Okay, so if two sides of a triangle are congruent to two sides of another triangle, and the included angle, so the angle between your sides, of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Okay, that's a lot of words. I promise it's really easy. So if I have my two triangles here,
The bigger angle has the bigger side.
yeah, the bigger angle has the bigger side. So since 80 degrees is larger than 60 degrees, this side RT here is the longer side.
And then the smaller side.
And then AC would be shorter. Okay, so we're comparing our sides and our angles within these triangles using this hinge theorem. Okay, and then we have the converse of the hinge theorem. Okay, that's using side, side, side inequality. So if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side in the second, then the included angle in the first triangle is greater than the included angle in the second triangle. So it's the same thing, but now you're given the sides length, and you have to see which angle is larger. So in my picture here, I have a side of 36 and a side of 33. 36 is greater than 33, so this would be your larger angle. Okay, so that angle there would be your larger angle since that side is greater. Hey, stop. So we're going to do a couple examples. Example 1, we want to compare the measures of side GF and FE. I don't know why my camera is doing this. So for this, we need to make sure two of our sides in each of our triangles are congruent. So we have side HG and HE congruent. I also know that they share the side, so that side would be congruent to itself, just like when we were proving triangle congruency. Okay, next I can look at the angles across from the two sides that I'm comparing. So my angles here are 28 degrees and 22 degrees. Since 28 degrees is greater, that means that side opposite has to be greater. So I have side GF compared to FE, and side GF has to be the greater side. So I can write my greater than symbol there.
But they're not.
Isn't that also greater than or equal to, or no?
Huh?
Isn't that also be greater than or equal to?
No, this was my blank space, ignore it.
Yeah. Gotcha.
Example 2. We want to compare the measures of angle ABD and angle CBD. Okay, again, making sure we have two sides of our triangles congruent. We have BC congruent to AB, and we share a side in those triangles, so we do have two sides congruent to each other. Next, I'm looking at these two angles right here. which is greater. So I need to look for the side across that is greater. That would be 16. Okay, so if I'm comparing angle ABD to angle CBD, ABD would be my greater angle. So I can write that it is greater than. Okay, so those are our two different theorems there, comparing sides and then comparing angles. Any questions so far? Okay, I want you guys to do 1 through 4 then, in that next section. Okay, numbers 1, 2, 3, and 4, compare each of those sides and each of those angles.
Well, that is just.
I know.
Me too. This is all we're doing. And if so, I'm going to get a house, but of course,
No.
this doesn't work. Okay.
All right, number 1, we're comparing side MR to RP. Okay, since 21 degrees is your greater angle, that means side MR would have to be your greater side. Number 2, comparing AD to CD. Since 38 degrees is your greater angle, AD would have to be your greater side. The measure of angle C compared to the measure of angle Z. Since angle Z's opposite side is greater, that means angle Z has to be the greater side. And then number 4, measure of angle XYW and the measure of angle WYZ. Okay, so XYW is right here and WYZ is right here. Since 42 is the greater side, that second angle there would have to be the greater angle. Okay, questions on those 4 problems?
No.
Okay, the next section's a little bit different. We're writing an inequality for the range of values of x, kind of like we did with our triangles before. But now we're just doing it for the side lengths. So in number 5, I know these two sides of both of my triangles are congruent and they share that side there, so I can apply this theorem. Now what I'm going to look at next is which one of my angles is greater. So 120 is greater than 115. That means that 4x minus 10 has to be that greater side. Okay, so comparing my sides here, I could say that side of 4x minus 10 must be greater than the side that we're comparing to, which is 40. Okay? From here, I'm just going to solve for x. So I'm going to add 10. So 4x is greater than 50. Divide by 4. Now x is greater than 12.5. So that means that x value has to be bigger than 12.5. So it could be 13, it could be 24, okay? Any value greater than 12.5 but not equal to 12.5, because then those two triangles would be congruent, and that's not possible since their angles are different. Okay, so that would be your range of values for x, anything greater than 12.5. Now we're going to do the same thing in number 6. So in number 6, I know my two sides of 60 are congruent and they share the side. So again, we can apply this theorem. So now, to find my range of values for this x right here, I'm going to look at the sides opposite those angles. And 36 is the greater side. Okay, so that means this 3x minus 3 here has to be less than that second angle. So we have 3x minus 3. It has to be less than 33. And again, I want to solve for x. So we're adding to get 3x is less than 36. Divide by 3. And x has to be less than 12. Now, if I'm talking about an angle measure, can my angle measure be negative? No. Your angle measure cannot be negative. But right now I'm saying my x values have to be less than 12. That would include all of your negative values up until negative infinity. So I need it where x is greater than 0 as well, because this angle has to be greater than 0. So I also need to say 3x minus 3 has to be greater than 0, because my angle measure can't be 0 and it can't be below 0. So again, I'm just solving for x here. So I'll add 3. So we have 3x greater than 3. So x has to be greater than 1. So now if I write this on a number line, just to make it a little bit easier for you to see, I'm going to put my 2 points here, 1 and 12. Okay, my first one, I have x values less than 12. Okay, so I have an open circle at 12 and all the values less than it, right? For this one, I have x values greater than 1. So open circle at 1 and all the values greater than 1.
Why is 0?
Because my angle can't be 0 or below 0. So it can't be, otherwise you wouldn't have a side measure in your triangle. So it has to be greater than 0. So I just solved, so x has to be greater than 1. Now I'm looking at the overlap. So that means my range for this one would have to be between 1 and 12. So my range, I have x values greater than 1 and less than 12. So they just have to be between those two values. Does that make sense? Okay, angle measure can't be 0 or less than 0. I did that because my x values originally here were less than 12. Okay, if I just say less than 12, that means I could plug in negative 5. But if I do that, I'm going to get a negative number. You can't have a negative angle. Okay? All right. Next page here, I want you guys to do 7 and 8. Okay, for number 8, you're going to have to do a little bit of thinking, and I want you to talk about it with the people sitting next to you. So you're just comparing those angles and then those sides.
Do you want to do that like this? If it's x is less than 1, or sorry, less than 1.
Because if it's greater, then you can plug in a number greater than it, and
Yeah,
it won't
that's
ever
true.
be
Yeah.
0.
The negative.
All right, I'm going to start going over these. So number 7, you're looking at the measure of angle BXA compared to the measure of angle DXA. BXA is less than DXA, okay, since DXA is opposite that side that has 8 as a measurement. For number 8, we're looking at side BC and side DC. Okay? Now, if I go back to number 7, I said this angle right here was the greater angle, right? And this one was my smaller angle, correct? Well, I can apply my vertical angle theorem here. These two angles are congruent, and these two angles are congruent. Well, if this one then would be my greater one, BC would have to be greater than DC. Okay? So all I did there was apply that vertical angle theorem, because your angle measures aren't going to change. They're going to stay the same, given that vertical angle theorem. Does that make sense? I'm going to skip 9 and 10. If you did them, that's great. Number 11. In the figure, BA, this side here, BD, BC, and BE are all congruent. Okay? So all 4 of those sides are congruent to each other. And I know AC is less than DE. So this side right here is my greater side. We want to compare angle 1 to angle 3. Okay, so angle 1's here, angle 3 is here. Now both of these sides contain angle 2. Well, angle 2 is going to be the same in both cases. Okay? However, I know DE is a greater side, meaning 3 would have to be our greater angle. So I can say the measure of angle 1 is less than the measure of angle 3, since AC is less than DE, and they both then contain angle 2. Does that make sense? Looking at our picture here. Greater side, opposite, greater angle, both contain 2. All right, the last couple here, we're just filling in the blank again. with less than or greater than. So number 12, we're going to compare side AB and BK. Well, if I look at the angles opposite those sides, they're not there. However, I can find their angle measure. If I look at triangle ABM, I have 40 degrees for angle A, 30 degrees up here. How can I find that angle right there? By subtracting. Okay, so to find this angle, I would take 180, subtract 40, subtract 30. Okay, so that angle there would be 110. Now, if this angle is 110, what does this angle have to be? What's the angle measure itself?
80 or 70.
70. Okay, those two angles make a straight line. Straight line is 180 degrees. Now I can compare my two sides. Well, since this angle right here is a greater angle, that means the side opposite has to be the greater side. So AB has to be greater than BK. Number 13, I have two sides here congruent, share a side in those triangles. Now I'm comparing side ST to side SR. So that means I need to look at these two angles. Well, there's an X for both of those angles, right? I don't need to solve for X in this problem. If I were to plug in any number for X, say I plug in 10. I'd have 10 minus 3, that's 7. And 10 plus 3, that's 13. Since you're adding 3 to this one and subtracting 3 from this one's always going to be greater because you're adding 3 to that same number that you would be subtracting 3 from. So that means side ST would always have to be greater than side SR. Okay, questions? Are we good? Comparing our sides using this hinge theorem? If you did the last two, you should have less than and less than for those ones. I'm not going to go through them, but that's what you should have for those last two there if you did those. Then you